Hi guys, maayong adlaw. Welcome to NatzMath TV. For today's video, my presentation is about the truth values for the conjunction and disjunction. We will have a separate video for implication or conditional and biconditional. Okay, so in logic, to test the validity of an argument, we have to determine first the truth value of the statement or proposition. When we say proposition, it is a compound statement composed of two or more simple propositions. So later, I will be presenting to you an example about how to formulate a truth table before we could identify or before we could determine the truth values of a given statement or of a given propositions. Okay, to start, let us have first the lesson objectives. At the end of this video, you should be able to formulate the truth tables of the different logical symbols of propositions. You should be able to determine the truth values of the proposition. And number three, you should be able to illustrate the different forms of conditional propositions. So as I've said, there are different kinds of statements or propositions. So we have the first two propositions, which is about conjunction and disjunction. Conjunction, we use the connector and for disjunction, we use the connector or. So for this video, we will focus in these two types of statements or propositions. So to start, let us have first the truth table for each of these two kinds of propositions. So we have here the first conjunction. Of course, we use this symbol. And for the variables P and Q, since we have two variables P and Q, there are four possibilities of truth values for a given compound statement. So first possibility is that if our P is true, or the first variable is true, and the second variable is also true, then therefore our compound statement, the whole compound statement is also true. Now, if the second possibility is that if our P is true, which is the first statement is true, and the second statement is false connected by and, then therefore our compound statement is false. And the third possibility is that if our P is false and our Q is true, our compound statement must be false. The last possibility is that if both P and Q are false, then the whole compound statement must be false. Now, in conjunction, the statement can only be true if both components are true. Other than that, the compound statement is false. So in conjunction, there's only one possibility that your compound statement could be true if both P and Q are true. Now let's proceed to the truth table for the disjunction. The same, we use this symbol for or, and we also have the same variables. We have two variables P and Q. Of course, since we have two variables, we also have these four different possibilities for a compound statement. If the P is true and the Q is true, then the compound statement for disjunction is also true. Another possibility, of course, is if the P is true and the Q is false, then the whole compound statement for disjunction is true. If the P is false and the Q is true, then the whole compound statement is true. And another, if the P is false and the Q is false, then the whole compound statement must be false. Now, as you have observed, this is an opposite to conjunction. In conjunction, we need at least true for both statements P and Q in order for us to have a true compound statement. But for disjunction, the statement is false if both components are false. Otherwise, it is true. So meaning, if we only have at least one true statement in either P or true in order for us to have a true compound statement for conjunction. If both are false, then the whole compound statement for disjunction will always be false. Now, let us proceed to negation. This is very important because we will also be using this symbol in our determining the truth values of a given proposition. So for the negation, we have here the truth table. Negation, we use the symbol negation or the not, meaning if the statement is true, the negation is false. If the statement is false, the negation of that is true. So meaning, the same, we have two variables P and Q, and there are four different possibilities. So if we are to negate P, which is this symbol, the not P. So if we have true for P, therefore if we are to negate this statement true, therefore this is false. The same here, if this is true, of course the not P is false. Now if this is false, the not P is true. Again, if this is false, the not P is also true. So this is just the exact opposite of the given statement. For example, if the statement is true, then a negation of that is false. If the statement is false, then a negation of that is true. The same happens for the Q. So we have here the Q, and the negation of Q is, we have the true here, of course, the negation of that is false. We have the false, the negation is true. Then we have true, it is false. Then we have false, it is true. Now we will be using this truth table for conjunction, disjunction, and negation in our examples. So let's proceed to our example. Let us have first the conjunction. For example, we are given, let P, today is Monday, and we let Q, it's a sunny day. Now if we are going to write this statement, P and Q, using conjunction and, so we can have, today is Monday and it's a sunny day. So this is our P, the first statement, and this is our Q, the second statement. It is connected by the word and because we are talking of conjunction. Now if we want to determine the truth value of this statement, we have to validate which of these four possibilities that this statement could fall. Meaning, for example, today is Monday. I would say today is Monday. Really, today is Monday. If we will assume that today is really Monday, so meaning this is a true statement that falls under this column or under this row. If this is a true statement, if today is Monday and it's a sunny day, so today is Monday and it is a sunny day, so meaning this is a true statement. So if the P is a true statement and the Q is also a true statement, that falls under this row. The P is true, the Q is true, meaning the whole compound statement is true. If today is not Monday, let us assume that today is not Monday. So this statement would be false. It's either under these two rows. If today is not Monday and it's a sunny day, so not Monday and it's a sunny day, therefore this is a true statement. The Q is a true statement while Monday or the P is not a true statement or is a false statement. So that falls under this row. So the P is a false statement. The Q is a true statement. So the whole compound statement could be false. Now another example. We let P 7 is greater than 10 and we let Q 3 plus 1 is equal to 5. We write a compound statement using conjunction, so we can have 7 is greater than 10, and since this is a conjunction, 3 plus 1 is equal to 5. Now if we are going to validate the first statement in mathematics, 7 is greater than 10 is a false statement. Nobody can argue of that because 7 is less than 10. So 7 is greater than 10 is a false statement, which is our P. Our P is false, and 3 plus 1 is equal to 5, which is also a false statement. So this falls under this row. P is false, Q is also false, therefore the whole compound statement is false. So the truth value of this statement is false. Another example, we let P as angle ABC is a right angle and we let Q as its measure is 45 degrees. So if we are going to combine these two statements into compound statement using conjunction, we can say angle ABC is a right angle and its measure is 45 degrees. So if we are going to validate this statement, angle ABC is a right angle. So let us assume that angle ABC is a right angle. So this is a true statement that falls under either of these two statements. Okay, ABC is a right angle. Now let's proceed to the Q. Its measure is 45 degrees, meaning if this is the first statement, the second statement is false. Why? Because the measure of a right angle is a 90-degree angle. So if this P is a true statement and the Q is a false statement, therefore that falls under this row. Our P is true and our Q is false. Therefore, the truth value for this statement is false, which is this part here. Okay, let's proceed to disjunction. The same, we have four possibilities. For disjunction, we only need one true statement in either P or Q to have a true statement for a compound statement for disjunction. Other than that, it is false. Let us have this example. Today is Monday for P, then we let Q as tomorrow is Tuesday. So for the compound statement, we can have today is Monday or tomorrow is Tuesday. Now if we are going to determine the truth value of this statement, and we would say if we will assume that today is Monday, then tomorrow is Tuesday. So today is Monday or tomorrow is Tuesday. So this falls under this row. Our P is true, which is today is Monday, and our Q is also true because after Monday is Tuesday. So that means the whole compound statement could be true. But if in reality today is not Monday, meaning the statement is false. If this is false, that goes to follow. If today is not Monday, of course, tomorrow is not Tuesday under this row, which is a false statement. Let's proceed to another example. Let P, I will wash my clothes, and we let Q, I will take a bath. So in compound statement, that can be translated as I will wash my clothes or I will take a bath. Now therefore, if I will wash my clothes and I will take a bath, so that means that falls under true, true, so therefore the whole statement is true. But otherwise, for example, I wash my clothes but I did not take a bath, so P is true, our Q is false. So that still becomes the whole statement is true. But how about if I won't wash my clothes but I take a bath? So that falls under this column or under this row, which is false for P and true for Q. So for this statement, if I would assume that I would really wash my clothes and I will take a bath, so the first statement and the second statement is true, therefore the whole statement is true. Now let's proceed to another example. We have here again the conjunction and disjunction, and we are given, we let P a true statement, our P is a true statement, our Q is a false statement, and our R is a false statement. And we are to determine or find the truth values of the following statement. Okay, so we write the equivalent of our statement here. P is equivalent to true statement, our Q is false, and our R is also false. Now, if we are going to determine the truth values of this statement, the negation of P and Q or R, okay? The negation of P and Q or R. So how do we determine the truth values of this statement given that P is true, Q is false, and R is false? So first things first is we have the P, Q, and R. Of course, we will refer our answer to this truth table. We have here the truth table for conjunction, and we also have here the truth table for the disjunction. First is, we will change the variables p, q, and r. Our p is true, we will change that with true. Our q is false, so we change that with false. And our r is false, so we change this with false. This time, we will start first with the terms inside the parenthesis, inside the grouping symbol. So, we have here the symbol and. So, of course, this is a disjunction because of this symbol. So, true and false. So, this is under the second row, true and false. So if the P is true and the Q is false, the whole compound statement is false. So therefore we have the not F. So true and false, true and false. So this is false. Then we copy or false. Now, for negation, as I've said earlier, the truth table for negation, if we would say the negation of false is true and the negation of true is false. So since this is not false, so therefore this is true. Then we copy or false. Now this time, since this is or, so this is now a disjunction. So this falls under the second row. True or false is true. Therefore, the truth value for the given statement is true. Okay, let's proceed to the second example. For example, we are to determine the truth value for this statement, not Q or the negation of R or P. Now, the same, we change the variables with the truth values here. So our Q is false, our R is also false, and our P is true. This time we will start with this grouping symbol, but we have here the not false or the not F, so therefore we will negate first the false, therefore this is true. So we copy the not F, so we have here the not F, so which is true, which is the negation of false is true. The same here, the negation of false is true, then we copy or true. This time we have both or. So true or true, this is under this row. True for P and true for Q. Therefore, this whole statement here is true. So this is true here and we copy true. The same true or true, still under this row. So therefore, this statement is true. So the truth value for this statement is true. Then next example. The negation of Q or P and the negation of R or P. So we start with changing the variables with the truth value. So we have here our Q is false, our P is true, then our R is false, and our P is true. This time we will have first the negation here. So we have false or true. This is or, so this is in disjunction. False or true, therefore this is true. That's why we have here the true. Then we copy the negation, we copy the and. Then the negation of not F, therefore that is true. We copy or true. This time we have the disjunction again. True or true, this is true or true is true. So therefore we have the negation of true is false and and true or true is true. Then therefore false and true, which is this column or which is this row here, false for P, true for Q, therefore the whole statement is false. This statement is a conjunction. So the whole statement is false. So meaning the truth value for this statement is false. Now let's proceed to our next example. We let P a false statement, Q a true statement, and R a false statement. Then we find the truth values of the following statements. So we have here a first statement. Then we have here the different equivalent truth values for the different variables. Our P is false, our Q is true, and our R is false based on this given. So if we wanted to find the truth values of this statement, again, we write the different truth values for each variable. So we have Q is true, our Q is true, our P is false, our R is false, and our P is false. This time, we negate the false here, which is not false. Of course, it is true. We copy first the negation, true or false, then we have the and, then the negation of false is true, then we copy and false. Then this time, we find the truth value of this statement, which is a disjunction. So this is true or false. This falls under this row. True and this is false, then the whole statement can be true. So we have the negation, so this statement is true, then we copy the and. This time we have true and false. So this is a conjunction. This falls under this row. We have true and false, so the whole statement is false. Then we also have true and false, the same, true and false. So therefore, this whole statement is false. And of course, the negation of false is true. So therefore, the truth value of this statement is true. Now let's proceed to our last example. Given not Q and P or not R. So substitute the different truth values of the variable. So we have our Q is true, our P is false, our R is false. Then we copy the not true, or we can write directly the negation of true, which is false. This time we copy the and, we copy the false, we copy the or, and the negation of false is of course true. Then the negation here, which is false, the negation of this statement not true is false, and false or true, which is a disjunction, false or true is of course, the whole statement is true. Then false and true, which is a conjunction, false and true, the whole statement is false. So therefore, the truth value for this statement is false. Okay, that's it. I hope you have learned something from this video. Thank you and God bless.